Hello, and thanks for joining us on this special recorded version of an introduction to applied window films and the opportunities for window film and National Glazing Solutions to improve the value and the payback of performance contracts. In addition to this industry specific summary, we offer several more conventional 1 hour lunch and learn topics you might be familiar with: an introduction to solar control window film, an introduction to safety and security films and attachment systems. And we also have three other non-energy, non-security window film topics. If you or anyone in your company would like to be part of these detailed 1 hour lunch and learns for any of these topics, either in person or virtually, just let me know. We've put together this training in order to accommodate some of the most common questions that we receive as it pertains to window film and performance contracting. Let's get started. As we consider how we can support performance contracting companies, our experience helps us to see two summary categories, indeed, two ways of working within an ESCO. That is, project design and project implementation. During design, you want to quickly consider whether window film will improve the payback and the project value. For those projects that make the initial cut, you need to know more specifically which products are the best for that particular building and how can energy savings be most accurately estimated. On this list, we're not thinking step by step A, B, C, D, but let's go ahead and start with what you might be most familiar with, and that is, why consider window film at all? And what about the window film brands? We'll then consider performance and appearance and some additional software. We'll take a minute to look at solar security films, and then we'll spend a little time on predictive energy savings and modeling, followed by economic analysis and incentives and rebate support, something that is probably perceived as pretty pedestrian, but we'll show you some potential pitfalls there as well. And then lastly, the engineered savings validation. But after project design, the projects you're then awarded and for which window film was selected as an ECM, you need to have the confidence that the same people who guided you through design will be there to live up to those commitments during implementation. During implementation, we want you to see, as your most trusted partner in this industry, as the #1 commercial window film company in America, licensed and operating in more than 30 states with a $1.5 million bond line in each of 2013 and 2014, installing over 3,000 projects per year. How can we help you achieve your implementation goals? For now, let's drill down into project design. The main reason to include any ECM is to provide value to your customer. In addition, from a competitive standpoint, you can make your proposal stand out due to higher energy savings and possibly even a security benefit. The security benefit, as we'll see later, can be particularly attractive to the schools you work with that are awarding contracts. You can also improve the ROI of deep retrofit projects because any project with an overall ROI longer than the window film ROI will benefit from the addition of window film. This is pretty similar to the next bullet point of using window film's quick payback to even fund other ECMs that would otherwise be too long a payback. Now, personally, this is maybe just my 2 cents, but I feel the greatest advantage that you can have is to be seen as a comprehensive solutions provider rather than just an HVAC company or a controls company or a lighting company that, quote, does performance contracts, because window film offers that benefit. And lastly, the addition of window film can even allow you to right-size some other components, such as HVAC systems, if you can reduce the max expected load. There are many reasons why you should consider window film, which probably starts you thinking down the road of, okay, which one? As we consider discussing window film brands with you, we don't want to minimize the very different capabilities of window film manufacturers when compared one to another. Some manufacturers are subsidiaries of multi-billion-dollar companies with histories dating back over 100 years. Others are small companies focused on particular technologies, like maybe they focus on exterior films or low emissivity products. There are good reasons to consider products from each of these manufacturers. With that said, however, one can quickly get lost among the thousands of products, each marketing itself to be the best at something. Indeed, there are some products, maybe 5 out of 1,000, that are truly unique. But unique to you is not equivalent to right or proper. Maybe what your project needs is indeed one of these 5 unique products. But maybe what it needs is the best support and warranty and price for a commodity product that everyone makes. So since we're not driven by product marketing, we're not marketing centric, we're project centric. We can focus on the needs of your project. Let me pause because this is as good a place as any to discuss something. There's no great place to put it, but it needs to be said. There is an appropriate function of product manufacturers like those listed here and of contractors like NGS. Although some of these manufacturers, not all, they'll present capabilities for a turnkey project implementation through a so-called premium network of program dealers. Make no mistake that you will likely not be subcontracting these manufacturers. Your project will be forwarded by the manufacturer and received by a local window film dealer who will then provide the implementation. What this might mean, I won't say necessarily means, but what this might mean is twofold. You'll have to qualify the skills, the insurance, project management, and bonding for a new subcontractor on every window film scope. And secondly, the new window film subcontractor may not, again, might, but might not, have a long-term partnership mentality. It could be all about this one job. Therefore, if something goes wrong, product delay, installation issues, or worse, getting caught in non-compliance to a prevailing wage reporting or safety regulation, they might be concerned only with getting out of this job intact. You'll see examples later where an ESCO chose to, in my opinion, commoditize window film and just ask their local tinter to give them a price. Long story short, he walked off the job when he realized his bid was too low. And you and your industry deserve the highest level of commitment from your subcontractors. So getting back to products now, there are occasionally, albeit infrequent, needs for a custom product. We at NGS, we know which manufacturers have the capabilities and the programs to deliver a custom product to your project. Not every manufacturer has the skills, not every manufacturer has the flexibility to deliver a custom product. So back to our context, although there are 1,000 or more window film products, solar control window films are basically designed to affect performance and appearance of the glass. Both performance and appearance can be viewed from the same vantage point. First, the question is, what is the film affecting? It's affecting the solar spectrum, which for us in our scope is comprised of the UV, the visible, and the infrared regions. Window film doesn't affect gamma rays and X-rays. Second, how is the window film affecting the glass? It's changing one or more of these three variables: the transmission, the absorption, and the reflection. So you can change transmission of any of these three things: ultraviolet, visible, and infrared, absorption, or reflection. The picture on the right is to illustrate three films in order to help you see performance as distinct from appearance. The film on the left has, among other things, changed visible and infrared by increasing the reflection in the visible and the infrared. That's why it looks shiny. The film in the middle has changed infrared, like the one on the left, by increasing infrared reflection, but it does not have visible reflection. And the film on the right has changed by decreasing the visible light transmission. It looks a little darker. but it has really not changed visible light reflection much. And these are only three examples to illustrate how we need to be careful not to necessarily associate performance and appearance. Let's get the film to do what we want it to do and then look the way we want it to look. This next slide goes on a little deeper to that reflective film sample on the left. Previously, I mentioned separating ultraviolet, visible, and infrared regions of the spectrum, but for this slide, we're going to put them all back together for a simplification showing total solar energy, including all three components. On the left, you see 100% of the total solar energy hitting this simplified quarter-inch clear glass. 9% absorbed, 7% reflected, 84% of the total solar energy is transmitted. On the right, you see the same 100% total solar energy impacting the glass. The absorption goes from 9% up to 34%. The reflection, as you might imagine from a shiny silver film, the reflected total solar energy increases from 7% to 52%, leaving the total solar energy transmitted decrease from 84% to 14%. This is simple enough. But what if the glass and or film combination is not so simple as quarter-inch clear glass? In your projects, we'll often need to leverage technology to make sure our estimates of savings are as accurate as possible. I estimate 60 to 80% of the time the actual glass is appropriately categorized as single pane tinted or dual pane summer low E or some other glazing type that's readily available in the simulation libraries. However, when the glass is not in the library, many fenestration folks will just pick something close. But your intuition tells you, and you would be right, that this can dramatically affect both the summer cooling savings and the winter heating penalty results. For that reason, we're prepared to do more work for you, making sure again that our savings estimates on these complex glass systems are as close as possible. The first thing when your glass is not in the 60 to 80% that's in the library is to determine the performance of the existing glass without film. It's great when as-built drawings are available, but our clients can rarely find the Section 8 glazing specs and plans. They might not have ever been looked at in 25 years, unlike a mechanical plan or electrical plan. For that reason, we've invested in tools that help us narrow down glass types by testing certain characteristics in the field. With these tools, we can confirm the existence of laminated glass and low E coatings, as well as the number of panes, glass strengthening or tempering, and glass thickness. In addition to nailing down actual existing performance, the criteria gained from these tools are very important to make sure the application of film doesn't cause another problem, like glass breakage or seal failure. Here in project design, we understand and we categorize the risks of inappropriate film-to-glass application so that we can help you avoid very costly problems later. So with now the existing glass performance measured, how do we determine proposed glass performance? Keep in mind, we're still talking only about the 20 to 40% of the time. We just can't use the library in the simulation model because this glass type's not included. Using tools from Lawrence Berkeley Labs, their quote windows and daylighting group, we can enter as much as we can find out about each pane of glass separately and calculate performance. In the red box you see is the calculation result. We can then use another LBNL tool to calculate performance of the pane to which the film is going to be applied by choosing the manufacturer's film here. This file can be imported to the first program window from the second program, which is optics. As we now have knowledge of before and after performance, we're almost ready to price the job and transition into energy modeling to calculate payback. There's one thing we should consider first, and that is solar security solution. The reason is simple. The increased cost to add a security solution at this point, an integral solution with the solar solution, that additional cost is pretty small. So let's see if your client can benefit from this solar security solution and then cost the project with or without that security upgrade. When you consider or when you think of solar films and security films, think of it this way. There are two main differences between a solar film and a security film, and that is the film strength and the adhesive strength. Security films are typically thick multi-layer films from 4 to 20 mils plus, versus a solar film is typically 1.5 layers, I'll say, 1 to 1.5 mil, much thinner. So the film strength is different. In addition, solar film adhesives are just designed to hold the thin film to the glass. Security film adhesives are designed to hold the broken glass to the film. So you understand a solar security solution is one film with both the benefits of a thick security film with security film adhesive integrated in it, a solar film. So let's take one look at a particular type of solar security solution, and that is our Tri-Shield, in contrast to what I mentioned earlier as more a conventional solar security solution. The best way to illustrate Tri-Shield is side by side with that other conventional solution. Both of these are very good, but they are also very different. Tri-Shield can do things that the other cannot when it's called for, in particular, smash and grab and school safety. A conventional solar security solution has a film like we talked about before. It's an integral solar film security film in one film. And it can be attached to the frame if need be with a wet glazed attachment and a mechanical attachment, but there's film on one side. The Tri-Shield solution not only has an interior solar security spall prevention film, it also has an exterior fragment retention film. And then put together with a structural sealant, the Tri-Shield encapsulates the window, increasing the performance above the conventional solar security solution. Now note that this concept of security solutions, it does not improve kWh or therms. The reason we discuss it with you is that you can get energy savings and protection in one film and for a small increase in price, which then allows you to go back and look like a more comprehensive solutions provider to your school or government building or wherever your contract may be. Let's now take a look at our product spec and pricing and get into how much energy can we save through modeling and simulation. For the next few slides, we're going to consider the tools that we use for predicting fenestration-related energy savings through energy modeling. Note that we're going to be comparing two simulation methods, and it is not our intent to belittle one of them. It is our intent to show the strengths of the other one. Many of you have some experience with estimating energy savings. Energy savings calculations can be as simple as a company Excel spreadsheet that they use for lighting retrofits, to performing energy modeling using data from an investment grade audit for a deep retrofit. When we at NGS consider energy modeling and energy simulations for fenestration, we start with a requirement that we must be able to construct a building shell that is significantly similar to the actual building. It doesn't need to be perfect, but it must be significantly similar. Then with our own site audit and the performance of the proposed glass plus film combination like we've been discussing, now we can create a simulation. At this point, I need to address the skeptics and admit We haven't yet determined whether our simulation is right. We haven't even determined if it's reasonable. In order to check whether a simulation is right or reasonable, we have to still perform some quality assurance steps, including first comparing our results to some industry guidelines such as the Energy Star EUI. Second, we can also compare our results to the PEU. The PEU, as you'll see in a moment, will tell us, just for an example, if we know that cooling for that building type in that location is about 30% of kWh, we can check our hourly simulation data against that benchmark. And lastly, we can compare our results to the actual utility bills. It's important to notice in utility bill analysis, we look, of course, month by month at three things: electric consumption, electric demand, and gas consumption. It should go without saying, I've got savings on the brain, that just because the actual annual total at a facility is 1,000,000 kilowatt hours, and the simulated annual total is 1,000,000 kilowatt hours, that is not enough detail, and it doesn't mean anything. So in order to do this work and do this QA, we have our work cut out for us. So our choice of simulation software is really important. There's a reason we use eQuest rather than eFilm, and as I share with you an example of these two simulation software choices, let me say they both had the same inputs in preparation for this comparison. Both eQuest and eFilm had the same existing and proposed glass spec. They had the same cooling and heating efficiencies. They had the same lighting power densities. They had the same HVAC control parameter. This is not about the quality of the input data. It is solely about the ability of the simulation engine to accurately predict savings. So what did a comparison between eQuest and eFilm simulation capabilities show us? Before we move on to the next slide, I want you to see, at least preliminarily, look at these two building shells. The one on the left, eQuest, looks much more like the actual building than the eFilm example on the right. And this is because where eFilm has about 10 building shapes to choose from, eQuest has the capability to construct a building shell significantly similar to the actual building. That again is our important starting place for energy modeling. So what else did the comparison show? This first graph is a graph of the results comparing eQuest to eFilm by energy end use. It's reasonable to think that two simulations are different due to the different building shells and shapes. However, they have the same square footage, the same number of floors, the same window area. We can't accept such a large difference between the models in cooling consumption. We've not yet said that eQuest is right. This large difference in cooling consumption for the baseline case, that is the building as it is without film, says only that although these simulations could both be wrong, they're different enough that they can't both be right. Let's look at the next graph, the heating baseline. Here again, the conclusion is that both models could be wrong, but they cannot both be right. Before we go on to the next graph, note here that at least the space heating baseline has the same shape between the two models. You would imagine that space heating would be very low in the summer and high in the winter, and they both have the same shape. The last graph, however, the simulated demand, shows a very distinctive difference between eFilm and eQuest and starts to direct your attention to which one is probably right. This is the Hilton in downtown Atlanta. Would anyone consider that the KW baseline for a hotel in Atlanta would not have a peak in the summer? So while we still don't know enough to know whether our simulation in eQuest is right, we are starting to show suspicions of the eFilm result. These are baseline comparisons without film. How do the simulation options translate into savings? Because at the end of the day, if they both predict a $50,000 a year savings, isn't that okay? The previous slide showing only a difference in baseline consumption, that building without film, this slide focuses on improvement or savings. This slide answers the question whether they predicted different savings regardless of their different baseline. The results are exactly what you might have expected. eFilm not only dramatically overestimated the baseline consumption, but also the savings. You can see here the eFilm savings is greater than the entire eQuest baseline. One side note, because this is a graph of savings, you don't see a difference in electrical equipment or lighting. However, both eQuest and eFilm have the capabilities to address daylighting controls. So if we had daylighting controls installed, we would see a difference in lighting power. A couple examples. If this was clear glass with daylighting controls and you put on a really dark film, you'd have an increased lighting power. On the other hand, if you had existing dark film and took it off and put up one of the films I showed you earlier, high light transmission, high heat rejection, it would decrease your lighting power. A question we often get at this point is whether the application of solar control window film will reduce the free heat that the building benefits from in the winter. This next graph shows that indeed both simulation engines predicted a heating penalty. And although the heating penalty for eFilm is more than twice that heating penalty for eQuest, they're still both really small when compared to the electric savings. What this graph is showing is a consistent difference between eQuest and eFilm in the three areas of comparison we mentioned earlier. Monthly comparison of electric consumption, electric demand, and heating consumption. I'm sorry to say, we still don't know if eQuest is right. We just know they can't both be right. They could still both be wrong. The next slide introduces the QA process where we determine which, if either of these simulation methods, might be right. As we stated earlier, our first comparisons, the QA steps for the simulated results, are to look at industry guidelines. The EPA says that the average proportion of a hotel's electric consumption due to cooling is 27%. eFilm predicted the proportion for cooling at 57%. eQuest predicted cooling at 26%. This is a good time to remind you we use the same assumptions in both models, and neither simulation had any miscellaneous tweaks made to it. This is as reported with the same assumptions. The next industry guideline is the Energy Use Index published by EPA for hospitality. The EUI for hotels within 2 standard deviations is between 50 and 88, with a median around 70. eFilm predicted the EUI at 114. eQuest predicted the EUI at 79. The next step was to compare electric consumption and demand and gas consumption, and that analysis as well showed a statistically significant match between the eQuest simulation baseline and the hotel's actual utility invoices. It's only at this step that we can say we think it's probably eFilm that's wrong and eQuest that's right. Until now, we only knew that they could not both be right. After we've done this, we've compared to industry guidelines and compared to actual consumption data, there's still one more step available where we can measure something before and after window film. This step is very similar to what you might consider measurement and verification, but it occurs on a smaller scale and we call it an engineered savings validation, an ESV. We will talk about ESV a little later because now I want to wrap up and focus on some other pre-bid activities. There is one pre-bid activity that in fact takes place very early in the process. What I want you to think about is what I'm about to show you. In reality, it does not come in the same order that it came in this presentation. In reality, this next activity is something that it would be the very first thing you did. But I wanted to give you a context of the complete eQuest discussion. I didn't want you to think that what I'm about to propose is the sum capability of our eQuest programming. I'd like to briefly present a special tool that we offer ESCOs to help you evaluate window film opportunities with no investment on your part, the preliminary assessment, also called the PA. Remember, again, although the PA is something we would really do for you very early in the process, maybe the very first thing in the process, I wanted to wait to present it until now so you'd have some context. The PA is a specific type of energy modeling summary, and it was designed to provide our partners with a kind of go, no-go gauge to decide whether they should spend any time and effort investigating a particular building for energy savings in window film. In order to provide a PA, all we need is the address. The inputs for the preliminary assessment include, as illustrated before, first, a building shell that is significantly similar to the real building shell. We have to start there. In addition, we're going to report to you our simulation inputs, our assumptions for HVAC efficiency, glass types, setbacks, economizers, other HVAC control schemes, as well as infiltration and lighting power density and plug load. To be sure, we're going to be estimating these values based on our experience and what we can see from outside the building. However, including the inputs in the PA report helps you and your customer evaluate the inputs and the assumptions that we've made. Lastly, in the PA is a section for results. We will include in our results a simple payback for 3 different film types, the same 3 film types you saw earlier. The preliminary assessment uses a good representation of the building shell, good estimates for inputs for associated energy systems and energy end uses, and the proven capabilities of the eQuest simulation software. Indeed, there are several assumptions associated with the preliminary assessment, but they are educated assumptions and utilizing the industry best software for simulation. You may be wondering, that's great, Mark, but how far off could these assumptions be? What if we assumed in our PA that the 30-year-old building hadn't had much work done, when in fact maybe it's been substantially upgraded by you during an initial contract, and now you're looking at window film for just a contract modification? Really, the question is, how much better could our simulation be if we had known the context of your request for the preliminary assessment? Included in this chart is just the HVAC KWH results for a few different assumptions. Let's say the base case as defined in eQuest is standard, no economizer, no resets, and a COP of 4.1, an EER of 14. What you get is the blue bars on the left. But what if these had previously been upgraded as noted on the chart? You can see our simulation could be off by 5% to 30% using the same HVAC system, the same set points, and the same occupancy. Therefore, when we work with you requesting a PA, it always helps for you to provide your knowledge of the context, whether this is a new contract, and likely very few HVAC modifications have been done, or a contract modification where there are likely to be existing improvements such as these listed on the chart. And now on to the incentives and rebates analysis and our economic analysis summary. These are the last pieces to help you prepare the best and most informed project proposal. And I know that this section is going to seem obvious to many of you. You have entire departments devoted to this kind of analysis. But I hope we can illustrate why things may not be as they seem, in particular with incentives. Ask yourself, what would you do to find out whether there is a rebate or an incentive available for window film? Maybe you could Google Oakland window tinter and ask the gal that picks up the phone, are there incentives in Oakland? Maybe you or they could ask their window film manufacturer. You can also go to Desire USA and comb through the results for Windows or contact the power company directly. And indeed, the best source of information may be the rebate specialists. But I suggest you come directly to us and let us pursue all these avenues and others, because you'll see soon that we may have a better chance of finding any incentive possible. Here's an example of a hospital in San Francisco. The ESCO trusted us to find the incentives available. We also started with Desire USA. We looked at the current PG&E commercial incentives, and we contacted our national rebate specialist. Unfortunately, everyone said there's no incentive available, quote, unless the existing glass was compliant with Title 24 already. Since it was not, we proposed to PG&E simulating 3 scenarios. Here, this is the table on the lower left. The 3 scenarios would be the actual base case, our simulation in eQuest verified through the QA process discussed earlier. The second simulation would be that base design plus the solar Silver 20 low E window film. So that existing base design and that base design plus window film. But they would not incentivize that. They would only incentivize the difference between Title 24. So we also simulated an example with Title 24 window characteristics, and indeed they did issue an incentive. This process took the incentive from 0 to over $15,000, and it only took 4 to 5 hours of our time. So with NGS securing all the incentives available for your clients, and with project costs nailed down, we can finally prepare the economic analysis for you to understand where this window film ECM fits in your project goals and make the best and most informed project proposal. I believe one more thing that sets you as an ESCO apart from traditional buyers is your economic IQ. You've proven the benefit to your customer of understanding more than simple payback. So we therefore provide detailed projected measures of worth economic analysis for every project and film combination you request. What we'll include in this analysis is the estimated annual increase in electric costs and tax rates, a depreciation schedule, and the warranty period for the selected film. And you'll see in a minute why warranty period is so important. On the right side of the calculator, you'll also see financing terms. Maybe we can help you secure financing, whether conventional financing or PACE financing. And any of you who have gone after conventional financing for a small scope for which the performance contract wasn't viable, you know that one of the most important things the lenders are going to consider is whether the contractor operates with sufficient quality that the customer will pay their bill. So our support has a lot to do with being approved in a conventional financing. The results of this projection you see are net present value, NPV, and internal rate of return, IRR, and both of these are significant financial ratios that no doubt you're providing already. So why include the warranty period? One more thing you can see from the sheet is the ratio of savings through the warranty period to project cost. In this example, the savings through the 15-year warranty period is nearly $2.5 million. The annual project cost in the upper right after incentives is about $400,000. Since it's a 15-year warranty, you get $2.5 million savings through the end of the warranty period. That's 6 times the project cost. Listen carefully. This window film is unusual in this respect. This makes window film projects stand out because, unlike other measures, there is no maintenance and no replacement cost during this 15 years. You can count on that warranty period for it to deliver performance through the warranty period with no maintenance and no replacement costs. So now that you have project scope and pricing and energy modeling simulation, many customers will ask at this point, can you guarantee the savings? And we typically answer the question, no, but we can prove it. You're in a unique position where you answer that question every day, yes, we can guarantee it. So the question becomes, what can we do to help you mitigate window film derating and mitigate your risk so that the project still makes sense to you? Can the proof that we offer non-ESCO customers still be helpful in your review? We think so, and our process for this is called the engineered savings validation. You can consider a fairly good parallel between what you know to be measurement and verification and what we call engineered savings validation, or ESV. The main difference is simply A, the scope of the study, and B, the target to which you compare the results. You all know, or likely know, the IPM, VPM, and V protocols occur over a very long period of time, the duration, and compare data to data. The ESV, on the other hand, compares data to simulation. It's similar to option D, except that the scope of an ESV is a smaller representation of the building shell than M and V, and the period of evaluation for ESV is typically a month or less. Although we can perform the ESV on a PTAC power supply, chilled water temperatures and flow rate, or using your building's own EMS. In this case, with a constant volume fixed flow fan coil, we just used a data logging anemometer. Once installed, the data shows supply air temperature over time, and from supply air temperature we can calculate runtime, and from runtime we can calculate improvement. Indeed, we could have put a data logger on the power source to the fan as well. ESV is a simplification over M&V, but it does have, nonetheless, project-specific requirements. Consider this example. What if you have a project for which your derating pushed an otherwise satisfactory ROI out too far to be viable? If you have a project like this, ESV might improve your derating to a point that the window film ECM makes sense again. So don't hesitate to let us know. So we're turning a corner now from everything we've said up to this point. Is how can National Glazing Solutions support you in project design? And we're moving now into how do we support you in project implementation? There is something that's so obvious to me that I'm sorry I occasionally forget to mention it. And that is, when you work with NGS, you will have seamless support from design through implementation. You won't be passed over the fence from the manufacturer to the contractor because we're a vertically integrated company that offers the best engineering and technical support in our industry. And our offering is followed by project implementation that is second to none. Again, although I think our message is clear enough that we desire to be your window film partner from design through punch list, I felt it was important enough that I say it that clearly. Let me say I realize it is a difficult task, but not impossible, for me to illustrate the value of working with NGS beyond just dollars and cents. And it's difficult to illustrate that because many people consider window film a commodity and they're looking for the lowest price. And while our pricing is always competitive, ESCOs work with us because financial risk isn't your only risk. When you're bundling ECMs in a performance contract, you also risk your reputation. You also risk future work if you bring in a subcontractor that isn't up to the task. And as the number one commercial window film company in America, we have licensing and the bonding and the insurance limits that most window tinters would not consider a necessary investment. We're also experienced in any form of wage structure, including Davis-Bacon and unions, utilizing both in-house and subcontracted installers depending on your needs and depending on the pace of your clients. We maintain great partnerships with minority and disadvantaged business entities in order to help you reach your set-asides, and we work every day to illustrate the benefits of working with a company like NGS that is truly national, that is truly vertical, and truly legal. We indeed work nationwide. We are truly national. You can see the installations we performed here in 2013. We maintain, as you see on the map, vertical skill sets and offices around the country. And we are legal. What you can see here is where we paid sales tax. This is one example of how we do business legally, paying our sales tax where others may just assume they won't get audited. I mentioned earlier the risk of working with other so-called national companies and window tinters. And I have here 3 examples of what can go wrong. And how can we illustrate our value and our way of doing business with ESCOs? The first example of what could go wrong is NGS was called in to see if we could help out because the ESCO had a local window tinter walk the site and walk off the job site. Our review put the specified product costs at $60,000. Our review put the Davis-Bacon labor rates at $45,000 for costs of $105,000. But it turns out the company that walked away had bid it and been accepted at a $60,000 turnkey job. But the ESCO is still on the hook. They have to get the work done, and they'll probably have to absorb $40,000 to $80,000 to piece it together. The second example is an ESCO brought an opportunity to us to provide engineering services and turnkey project pricing for a convention center. A window film manufacturer had provided the ESCO with estimated payback from energy savings at 3.5 years using eFilm. Using eQuest and much more appropriate building shells and HVAC efficiencies and occupancies, we put the payback at 14 years. Due to the discrepancy, the ESCO now had to spend some money, and they had to have their engineers determine payback, which when they were done, they concluded it was approximately 12 years. And the third is an example of execution. We were brought in to complete a large-scale frost striping project. Now, I realize you're not likely to specify or bring in a decorative film like this. The point, as I said, is in the execution. On this project, the architect had removed 2 prior window film contractors due to the quality of work and inability to accurately cut and install the intricate line pattern. The last of the 2 window film companies actually ended up scratching hundreds of lights of film when they tried to remove the film they had incorrectly applied. The project specifications were so tight that the lines had to be computer cut, not hand cut, and masked and transferred to thousands of linear feet of interior glazing. The first thing we did was sit down with the architect, show the architect the necessary adjustment to the specification to suit the application. We then executed the computer plotting and installation that exceeded that architect's expectations, resulting in additional work in that building and with that architect on other projects. These are examples of what can go wrong, but we also have examples of clients that have worked with us over and over again. Don't worry, we're not going to discuss the minutiae of each of these NGS customers. The purpose of this list is to highlight two dramatically different customer types in order to highlight our flexibility and capability to meet broadly scoped customer needs. On the left are some of the largest retail customers in America, requiring a scope of work typically under $10,000, but in project rollouts that can be over 1,000 locations in a relatively short time. In order to accomplish this, we've built a huge network of partners that can help us in scoping and pricing projects. Now, listen, you'd be surprised, or maybe you wouldn't be surprised, to find that many of the so-called big companies in the U.S. have no capability from their headquarters in Dallas or LA or even Atlanta to respond to a site visit in Kansas City. They can do a big job in their town, but outside, every visit is an experiment. Our national accounts presence keeps us relevant and current in markets nationwide. Of course, on the other hand, there are window film companies that have a national network, but they haven't proven their ability to bring large crews together under their leadership to tackle some of the country's largest window film scopes in the last few years. This brings our attention to some of the projects on the right side. Here again, I'm not going to read the customer list to you, but you can start to see how our ability to be both truly national while concurrently installing large projects for ESCOs and non-ESCOs is why we're the #1 largest commercial window film company in America. If you have considered or installed window film before, you've likely experienced that everyone says they can do it. It should come as no surprise that everyone wants to be your best friend. But when you choose someone else because of their perceived national presence and success, I truly suggest that you keep your eyes on the LinkedIn Window Film Professionals group, because that supposed national company is going to be out advertising, hey, I need an installer in Dallas. I need an installer in Chicago. They're out looking for installers to help them meet their commitment they made to you. And I'm sure you see the dots connecting here, that these are naturally installers they've never met and with whom they're going to experiment on your project. Just as a recap, project design and project implementation. Again, offering window film brands across the spectrum, asking you to consider separately performance and appearance, understanding the Lawrence Berkeley software and how we use that to help you derate less or to have a lower derating on your window film ECMs. We introduced solar security films. Any more questions on that? We have a separate 1-hour lunch and learn for that. And then we discussed how do we do predictive energy savings and modeling? What is our software and what are the results? We considered economic analysis and how to request that you just let us go get the incentives for you. And then lastly, in design, we considered the engineered savings validation. We followed that up with about 10 minutes discussing who we are and why work with us as the #1 commercial window film company in America, who's licensed and bonded and able to meet your project needs as we've done in the past year after year. Thank you very much for your participation and for your attention.